All right, in this video, I'm going to teach you guys how to graph secant x and cosecant x. And really, if you know how to graph sine and cosine, secant and cosecant x, there's just an extra step or two, okay? So before we do any graphing and plotting, if I ask you what is the reciprocal function for secant x, you would say, well, the reciprocal identity of secant x, right, is 1 over cosine x. And so before we do any plotting, whenever you see a variable in the denominator, you know that there's a restriction. In other words, x can't equal to 0, right? And so if you remember in the previously when we studied rational functions, the way we find, whenever you have a variable in the denominator, right, you know you have to exclude whatever that value that's going to make the denominator 0. So long story short, right, we're going to have to find vertical asymptotes again. And the first way, or the way you find the vertical asymptote, right, is you set the denominator equal to 0, and then you solve for x, okay? So knowing your unit circle, right, at what radian measurement, because we're always going to be in radians, is the x value 0. And if you know your unit circle, right, you're going to have pi over 2 and 3 pi over 2. Now remember, trig functions are periodic, meaning they repeat. And so it's no different with the vertical asymptotes. The distance between these two first vertical asymptotes, right, I would do 3 pi over 2 minus pi over 2. That will compute the distance. You're going to get 2 pi over 2, which is just pi. So that distance is just pi. And if I want to state all the vertical asymptotes, I would say all x, we could just say x is equal to my first vertical asymptote, which is closest to the origin, which is pi over 2, plus pi n. Okay, so I just stated all the VAs. I've only gotten 2, right? But remember, you can go infinitely around the unit circle, and you'll see this on the graph once I plot it with you, okay? So once you have the vertical asymptotes, right, if you think about it, right, the domain, right, we have to exclude these values. You can state the domain, all x cannot equal pi over 2 plus pi n. Because remember, the graph can never ever cross a vertical asymptote in a rational function. It's no different over here. Okay, so on a quiz or a test, make sure you know how to solve for VAs. That's going to be the most likely the type of question I will ask you. But let's plot it and let's see if all my VAs are going to repeat like this, pi over 2 plus pi n. So how do I graph secant x? Well, I would start by recommending that you graph your cosine x. Okay, so let's write out all our values here on the x-axis. And maybe I'll graph 2 periods, okay? So let's go in the negative x direction, negative pi, negative 3 pi over 2, negative 2 pi. Okay, so start by graphing your cosine graph, right? Because secant is 1 over cosine, and I'm going to graph a dashed line, right? So cosine of 0, of course, is just 1, right? That's the x value. Cosine of pi over 2 is 0, and then so forth. Make sure I write negative 1 over here. And make sure you go into negative x-axis. And the way I'm going to connect my cosine graph is with a dashed line, because this is not the actual graph that I'm graphing, right? I'm graphing actually secant x, but you need to do this by hand if you want to graph the secant x graph. Okay, so going back to our vertical asymptotes. Remember, these are our first 2 vertical asymptotes, right? Pi over 2 and 3 pi over 2. So pi over 2, right? 3 pi over 2. And we said there's a distance of pi units, right? And so that means I can keep going right here, right? If I keep going, right, the next VA, of course, would just be 3 pi over 2 plus another pi. And if you add 3 pi over 2 plus pi, you'll get 5 pi over 2, and so forth, okay? And why don't you just draw all the VAs here? Notice the VAs are going to intersect at where the cosine graph hits the x-axis, or in other words, the midline. All right, so I still haven't graphed the secant x graph, but if you remember from Math 3, the way you graph the secant or the cosecant is you just draw these mini parabolas at the minimum and the maximum values. Okay, so I just draw many parabolas And this would be basically one period, okay? Let me draw this out here. The distance from here to here, which is one cycle, right? The shortest portion of the graph before it starts repeating. This would be one period. And the way you calculate the period, right, aside from the graph, just looking at the equation, is you know whatever the period of your secant graph is, right? So the general form, again, let me give you the general form. The general form is still going to be, f of x is equal to a secant parentheses b x minus h, close the parentheses, brackets plus k. The period is still going to be just the equation 2 pi over b, okay? Because it's dependent on whatever cosine is. Now, I must say that the a right here, this is not a real amplitude. So we'll call it a fake amplitude, because if you look at this graph, right, there is no distance between your max and your min, okay? And so, there's no distance between the max and the midline, or the min and the midline. Because if you look at the curve, right, it just goes on forever. So there's no such thing as an amplitude in a secant or cosecant graph. Okay, so this is one period, right? And then, of course, this would be another period. The distance from here to here is another full period. And so really I sketched two periods with you in this particular secant graph. All right, so we have the domain, we have the range now. You can look at the graph, right? What is the range of this function? The range, right, your y value can be pretty much anything, but it goes up to -1. If you're going from minus infinity, you're going to stop at -1, right? And then union mark, it's going to stop at, it's going to restart at +1 and then go on into infinity. Okay, so that would be the range. It's a little bit easier to observe after you graph it. Okay, so if you understand how to graph secant, the way you graph sine x is going to be the exact same thing, okay? So if I ask you to graph sine x, if I ask you to graph cosecant x, cosecant x, right, is just 1 over sine x. And just like what we did in the beginning of the previous example, I'm going to ask you, how do I find the vertical asymptote? Well, the way you find the vertical asymptote is you set the denominator equal to 0 and you solve for x. Okay, so my first two vertical asymptotes in my unit circle is such that the y value is 0, right? Sine of what angle gives you 0 radians? Sine of what angle gives you a y value of 0, right? You're going to get x is going to be equal to 0, right? And x is equal to pi, okay? So these are, again, my first two VAs, right? The distance between these two, of course, is just pi. And if I were to state all the vertical asymptotes, I would state x is equal to 0 plus whatever that distance is, plus pi n. And then, of course, you can simplify it. You could say x is equal to pi n. Okay, so that would be all your VAs. Once you have the VA, you can also state the domain. All right, the domain is all x cannot equal to pi n because the graph cannot cross those vertical asymptotes. Otherwise, you'll be dividing by 0. And then we'll talk about, again, the range. But, once you see the graph, it's going to be the exact same thing. Minus infinity to -1, union mark 1 to infinity. All right, so let's finish this problem by graphing our cosecant x graph. Again, let's write out our commonly used x values in our x-axis that are on the unit circle. Okay, so my first, the first thing I'm going to do when I'm graphing cosecant, right, is graph my sine function, which is, sine of 0 is 0, sine of pi over 2 is 1, etc., etc. And just like you did on the previous problem, right, draw a dashed line when you graph sine x, because that's not the actual graph you're graphing. The actual graph you're graphing is the cosecant function, okay? So our first two VAs, right, were x is equal to 0, x is equal to pi. So you would have a VA at the y-axis basically over here, right? And these VAs always repeat at a distance of pi, okay? So the next VA, of course, would be at 2 pi, right? And, of course, we've stated all the VAs. And so if you just look at the graph right now, right, again, draw these mini parabolas at the minimums and the maximums, right? This would be one full period, okay, of the graph. This is one period, which is 2 pi radians. Again, that's the horizontal distance. And then, of course, if you keep graphing, right, a little bit more, you would be graphing 2 periods. So this would be another period, right? Vertical asymptotes and mini parabolas. So basically, I have 2 periods sketched out here for you, okay? So again, the general form, pretty much the same. You're going to get y is equal to a cosecant brackets, parentheses, x minus h brackets plus k. That's the general form of your cosecant. Again, no such thing. We call it a fake amplitude. I don't know. It's not a real thing because you're never going to be asked to find the amplitude of a cosecant function. It just doesn't exist. But basically, if you see this a, it will be applied to your, your sine function or your cosine function, but it's not a real amplitude because you can see your parabola just goes on forever, okay? All right, so that's it for your secant and your cosecant parent functions. I will go over some examples of these in class with you.